Before we cover dividing polynomials, I want to review integer long division. If we have 724 divided by 3, this first number is called the dividend, and this second number is called the divisor. In order to perform long division, we write down our divisor with the long division symbol and our dividend inside the long division symbol. And then we look at 3 and decide how many times 3 goes into 7. 3 goes into 7 2 times. Now we take 2 times 3 and get 6, and we write that answer below our 7. Then we subtract 7 minus 6 to get 1. Then we drop down this 2. Now we have to look how many times does 3 go into this number, 12, and the answer is 4. So then we take 4 times 3 and get 12, and write that answer right here. And then we subtract. 12 minus 12 is 0. Drop down this 4. And then we look, how many times does 3 go into 4? And the answer is 1. Then we take 1 times 3, which is 3, and write that answer here. Then we subtract. 4 minus 3 is 1. This 1 represents our remainder. Many times you will just have to write remainder of 1. But I want to write the remainder slightly different. If our remainder is 1, I can write our remainder as 1 over our divisor. So our answer is 241 and 1/3. This 1/3 is made up of my remainder and my divisor. This answer is called the quotient. Let's look at dividing polynomials using long division. This first polynomial is a quadratic polynomial, and the second polynomial is a linear polynomial. So I'm going to divide, my dividend is this polynomial, and my divisor is this polynomial. I'm going to divide a quadratic by a linear polynomial. To do that, again, I'm going to write my divisor, followed by the long division symbol, and then my dividend underneath the long division symbol. And the process is going to be the same. I'm just going to get my numbers a little bit differently. Before, I looked at 3 and 7 and decided how many times 3 went into 7. I'm going to kind of do the same thing here, but I'm just going to look at my leading coefficients. So I have an x and I have a 3x squared. I'm going to ignore this minus 3 and I'm going to ignore the plus 11x plus 1 and look at just the leading coefficients. So how many times does x go into 3x squared? What do I need to multiply x by to get 3x squared for an answer? Well, I'm going to need a 3 and an x, because 3x times x is 3x squared. Now, just like before where I took 2 times 3 and got 6, I'm going to take 3x times x minus 3. 3x times x minus 3 is 3x squared minus 9x. I have to distribute this 3x to both of these terms. And just like before, I'm going to subtract, but I need to make sure that I subtract this entire polynomial, so I'm going to put it in parentheses. So I have 3x squared minus 3x, which is 0, and 11x minus negative 9x. Well, minusing a negative gives me a positive, so I'm going to have 20x. Then I drop down this plus 1. Again, I'm going to look at my leading coefficients. 20x and x. How many times does x go into 20x? The answer is 20 times. Now I need to take 20 times x minus 3 and write my answer right here. 20 times x minus 3 is 20x minus 60. And then I want to subtract, but I need to subtract my entire polynomial, so I'm going to use parentheses. 20x minus 20x cancels out. 1 minus negative 20 gives me positive 61. If you look, I'm never going to make this x look like 61. X won't go into 61 because there are no x's here. So 61 is my remainder. So I'm going to write my remainder as a fraction over my divisor. And I'm going to need to make sure that I add that term into my polynomial answer. So my answer is 3x plus 20 plus 61 over x minus 3. Don't forget to put this plus sign right here for the remainder. This second example, I have a cubic polynomial divided by a quadratic polynomial. They're both written in standard forms, but if I look, I have x to the third power, x squared. I'm missing an x to the first power, and then I have an x to the 0 power, a constant. If I look at my quadratic, I have an x squared. I'm missing an x to the first term, and I have a x to the 0 term, a constant with this 4. In order to do long division, I need placeholders. So to set up this problem, I'm still going to use long division, but I need placeholders to mark out all the x's that I'm missing. So I can't just write x squared plus 4. I need x squared plus 0x plus 4. I only need placeholders after my leading coefficient. I don't need to put a plus 0x to the third in front of this leading coefficient. And for my dividend, I also need a placeholder. X cubed plus 5x squared plus 0x to the first power minus 2. I can always check by looking at my coefficients. 2, 1, none. 3, 2, 1, none. At this point, the division is the same. How many times does x squared go into x cubed? X times. Because x times x squared gives me x cubed. So I'm going to take x times this entire polynomial. So I'm going to have x times x squared, x times 0x. Well, my coefficient's going to be 0, and my x term is going to be x times x, x squared, plus 4x. And I'm going to subtract that entire polynomial, so I'm going to put it in parentheses. Now the reason we have placeholders is so that our subtraction lines up. X cubed minus x cubed gives me 0. 5x squared minus 0x squared gives me 5x squared. 0x minus 4x gives me negative 4x. Drop down the negative 2. How many times does x squared go into 5x squared? Positive 5 times. 5 times x squared plus 0x plus 5. I'm going to write my answer right here. 5x squared plus 0x times 5. 0 times 5 is 0x plus 20. I still want this placeholder here, so I can do my subtraction. 5x squared minus 5x squared gives me 0. Negative 4x minus 0x is negative 4x. Negative 2 minus positive 20 gives me negative 22. Since my x right here has a lower degree than my divisor, negative 4x minus 22 is my remainder. Notice that my leading coefficient is negative. I don't want my leading coefficient to be negative. I want my leading coefficient to be positive. So I'm going to rewrite this problem by factoring out a negative 1. Negative 4x minus 22 is equivalent to negative 1 times 4x plus 22. If I distributed this negative 1 back into the parentheses, these two expressions are the same. Now I could rewrite this without the negative 1. So I'm just going to write it as negative quantity 4x plus 22. This expression is equivalent to this expression. If I distributed this negative sign back into the parentheses, I would get minus 4x minus 22. And the reason I do that is so when I write my remainder, I have plus negative 4x plus 22 over x squared. I don't need my placeholder when I'm writing my remainder, plus 4. So my answer is going to be x plus 5. Now I have plus this negative. Well, since I'm adding a negative, that's the same as subtracting 4x plus 22 over x squared plus 4. Both of these problems were solved using long division. Long division isn't the only way to do division of polynomials. There's another method called synthetic division. Synthetic division is a little bit easier, it's a little bit quicker, but the limitations are I have to be dividing by a linear polynomial. I can divide any polynomial by a linear polynomial using synthetic division. To set up synthetic division, I'm going to put a little box here, and then I'm going to list all the coefficients for my dividend. I have 1 x cubed. I have 0 x squareds. Notice that I still need a placeholder. I have negative 14 x's, and I have 8 constants. So I have 1 x cubed, 0 x squareds, negative 14 x to the firsts, and 8 x to the zeros. Well, x to the 0 is just 1, so I have 8 ones, 8 constants. Now I'm going to skip a horizontal line and put a horizontal line in with a box below my constant to catch my remainder. And inside this box, I'm going to write down the 0 of this linear polynomial. The trick is, I don't want to write down 4 here. I want to write down the x value that makes this 0. So the number I'm going to write here is negative 4. Remember that this number has to be the 0 of this polynomial. Now the process of synthetic division, much like the process of long division, is just an algorithm. We have to do the same thing over and over and over again until we get our remainder. Step 1 in synthetic division. Drop this number straight down. Now I need to take this number times this number and write the answer right here. Negative 4 times 1 is negative 4. I'm going to write that answer right here. Now I'm going to add 4 plus negative 4. Now I'm going to do the same thing. Negative 4 times this number. Negative 4 times negative 4 is positive 16. I'm going to write that answer here. Then I need to add negative 14 plus 16 gives me positive 2. Negative 4 times 2 is negative 8. Negative 8 I'm going to write right here and then add. So the algorithm is drop this first number straight down, multiply, add, multiply, add, multiply, add. Now to interpret our answer, our highest power of x was x cubed, and we divided by an x to the first power. So in reality, we have an x cubed and we're dividing by an x to the first. Well, when we have an x cubed divided by x to the first, it's going to be knocked down by 1 degree. So this x cubed column becomes my x squared column. And my x squared column becomes my x to the first. And my x to the first becomes my x to the 0 power. Every power has been knocked down by 1 degree. So my final answer is 1 x squared, negative 4 x's, and 2 x to the 0 powers, 2 constants. And in this case, I have a remainder of 0. So I don't need to write plus anything. If I had a remainder, I would write my remainder just like I did in long division. My remainder over my divisor.